Welcome friends to my channel. Now in today's lecture I shall going to start the second chapter of GPL, that is viscosity. Okay, liquids. Okay, so the first question that arises, what is viscosity? Okay, suppose we consider a liquid layer, say AB. Okay, and this is another layer above it, this is CD, and another layer below it, this is say EF. Okay, we consider a layer, liquid layer AB and two other layers, CD is above the liquid layer AB and EF is below the liquid layer AB. Now obviously the velocity of the upper layer is greater than this layer AB and the velocity of the lower layer EF is less than AB. Okay, so the upper layer moves faster than AB and the lower layer moves slower than AB. Okay, so consequently what happens, the lower layer will tend to decrease the velocity of the upper layer and the upper layer will tend to increase the velocity of the lower layer. Okay, so in this way the relative motion can be destroyed. How? The upper layer will try to increase the velocity of the lower layer and the lower layer will try to decrease the velocity of the upper layer. Okay, so in this way the relative motion is destroyed, and this happens in such a way that as if something, a backward dragging force acts on the liquid layers. Okay, now see, this backward dragging force is called viscous force. Okay, so velocity of CD is larger than AB and velocity of EF is smaller than AB. Okay, the upper layer will tend to increase the velocity of the lower one and the lower layer will tend to decrease the velocity of the upper layer. Okay, so in this way both the layers will try to destroy their relative motion. Okay, so in this way their relative motion is destroyed in such a way that a dragging force acts tangentially. Okay, in this way their relative motion is disturbed as if something, a backward dragging force, acts tangentially on these layers. So this dragging force is called viscous force. Okay, this dragging force is called viscous force. Okay, and viscosity is the property by which a liquid opposes the relative motion among its different layers. Okay, so viscosity is the property by virtue of which a liquid opposes the relative motion among its layers. Fine. Okay, the relative motion is disturbed by this viscosity property. Okay, now if we take two layers of a liquid which are separated by distance say dr, okay, and if they are moving with a relative velocity dv, then viscous force is proportional to velocity gradient, that is dv dr. Okay, if we take two layers which are separated by small distance dr, and if they are moving with a relative velocity dv, then viscous force is proportional to velocity gradient. Okay, and also viscous force is directly proportional to the area of the liquid layer. Okay, viscous force is directly proportional to the area of the layer. So what we can write by combining these two? Okay, by combining these two, we can write F is proportional to A into dV dr. So here we introduce a constant, say eta, and this is called coefficient of viscosity. Okay, here the negative sign indicates that viscous force acts along the opposite direction of the flow of liquid. Okay, if this is the liquid motion, then the viscous force acts in the opposite direction. Okay, so minus sign indicates that viscous force acts on opposite direction of the liquid flow. Okay, fine. Now if we make A and dVdr1, if we make A and dVdr1, and if we take the magnitude of this force, then this is becomes to eta. Okay, so coefficient of viscosity is the tangential force acts on unit area to maintain the unit velocity gradient. Okay, so if the tangential force that acts on unit area and it maintains the unit velocity gradient, then it is called eta. So eta is basically the tangential force acting on unit area to maintain the unit velocity gradient. Okay, so eta is the tangential force acting on unit area to maintain the unit velocity gradient. Okay, now if we can write eta into A into dv dr, now we will be able to find out the dimension of eta, that is f dr by A into dv. So what is the dimension of force? mlt to the power minus 2, and the dimension of length is L. A is what? L square, and dv is what? lt to the power minus 1. Okay, so if you calculate it, then the dimension of eta becomes n L to the power minus 1 t to the power minus 1. So this is the dimension of eta. Okay. Now eta is measured in terms of decapoise and poise, that is SI unit is decapoise, okay, and its CGS unit is poise. Fine. And there is a relation between them. 1 decapoise, this equals to 10 poise. Okay. So in our today's lecture, I shall introduce the concept of viscosity and viscous force, okay, and obtain the dimension of viscosity. Okay. Now in our next class, that is second class, I shall going to discuss about the different types of flows, okay, of liquids and few other issues. Okay. If you like my video, then kindly subscribe my channel. Thank you.